So, welcome back, everyone. Hope you had a good lunch. Like what we just finished the lunch in Thailand, but for the afternoon sessions, we're gonna divide it into two parts as well. So the first part of the afternoon sessions, we have 6 participants, and after that, we're gonna have 9 participants before we end this symposium. So before we get started, I would like to give you some announcements about the rules that we need to follow. So you all have 12 minutes for presentation and 3 minutes for Q&A. So after 10 minutes, we're gonna ring the bell like this. So it means you need to be aware that you have 5 minutes left for the presentation. And if you hear 2 times of the bell like this, it means you have just only 2 minutes left. So be careful about the running out of time. Okay, but before, I would like to check the participants that gonna present the topics first. Let me ask. So Ms. Batgerel, are you here?
Yes, I'm here.
Okay, so could you please share your screen and we will start right on time.
Okay.
Okay, so may I introduce you a little bit before we get started? So Batgerel Solongo is a student from Tokyo University of Agricultural Science and Technology, Japan. So she will present on the topics of the development of Mongolian food rich in barley and buckwheat flours and its evaluations. So please welcome Ms. Solongo.
Okay, thank you. Do you hear me?
Yep.
Yeah. Let's start. Good afternoon, dear professors and participants. I'd like to thank you for introducing me. My name is Solongo Batgerel. I had enrolled at Tokyo University of Agriculture and Technology in this last April. My supervisors are Professor Takahiro Saito and Associate Professor Masatsuko Tamura. My research topic is the development of Mongolian foods rich in barley or buckwheat flour and its evaluation. But now is just the only plan because I had enrolled in this semester, and we are discussing my research topic. My presentation has the following parts. In the introduction part, I prepared some information about Mongolian background statistics. Mongolia is the 18th largest country in the world, and the Mongolia area is 1.56 million square kilometers. We see the land types of Mongolia in Figure 1. Nearly 90% can be used for agricultural and pastoral pursuits. As shown in the diagram in yellow, only 1% is used for arable land. But this amount is bigger than some small countries. You can see in the figure 2 that 68% of Mongolia's total arable land is planted with wheat, and others use it for plant vegetables, potatoes, and other grains such as buckwheat, barley, oats, and rye. Table 1 shows the amount of harvested crops between 2018 and to 2020. We see the amount of harvested wheat much more than other crops. An example, for example, in 2020, the amount of harvested wheat was 406.1 thousand tons, but barley and buckwheat and other grains crops had only 3,000 tons. These statistics indicate the wheat usage and amount of crop is absolutely higher than the other crops. And truly, wheat is used to produce almost all Mongolian flour products. In contrast, barley or buckwheat are consumed as only whole grains for meal. There isn't any processing factory for barley and buckwheat flour, but therefore, amount of harvested crops of these kinds of crops is very low. But because of the barley, especially buckwheat, nutritional components, Mongolians prefer to use buckwheat. This trend is increasing. Figure 3 shows the Mongolia's annual food consumption of standard population of as of 2018. As shown in the diagram, Mongolians traditionally eat a lot of meat and meat products, flour and flour products, and milk and dairy products. And it 5% is the amount of usage consumption of whole grains except wheat. According to a study on the actual food consumption of the Mongolian population, the average daily caloric was 1,961 kilocalories. In figure 4 shows that 6,300, which is supplied by the grain groups. But the amount of fiber they received only 7.3 grams per day, which indicates there is a high consumption of refined grains. In 2019, in the report of the Center for Health Development, the leading diseases in the Mongolian population were respiratory diseases, 18.6%, the digestive diseases, 16.3%, and cardiovascular diseases, 11.7%, and so on. Another study found that 61% of men and 51% of women had overweight or obesity in Mongolia. These food consumption, amount of crops, and health statistics indicate that the Mongolians should pay more attention in their diets. Research on barley and buckwheat had been increasing through the world due to their functional components and health benefits. Some studies in abroad have been concentrating to replace a certain percentage of wheat flour by functional materials such as barley and buckwheat. For instance, group of Professor Dr. Saito and Dr. Tamura in Tsunami University have developed a dumpling skin and noodles containing high amounts barley flour instead of wheat flour. And recent year, many experiments and studies have been conducted to use buckwheat to produce low gluten and free gluten bread, pasta, noodle, cookies, and beer. Therefore, my research topic is developing Mongolian foods such as foods that have high amount of barley or buckwheat flour and evaluate the functional components and starch digestibility. This is a food that one of the most popular Mongolian dishes use it on ordinary days and on holidays. The main ingredients of the bowls are wheat flour, dough, and meats. Excessive consumption of the bowls, especially on holidays, can adversely affect the digestive system. Therefore, it might be useful to replacing high amount, impossible high amount with flour by replacing the with buckwheat or barley flour. Now we are discussing the materials will be used can barley flour or buckwheat flour. For methods, the dough of bowls will be prepared following the sample preparation methods described by Tamura, Dr. Tamura and each others. In order to simulate the starch hydrolysis, we will use in vitro gastro small intestinal digestion model. For future prospects, increasing the use of barley and buckwheat flour instead of wheat flour can make a real contribution to the health problems of the Mongolian population, such as digestive diseases, overweight and obese, and malnutrition. Thank you for the attention.
So thank you so much, Ms. Solongo. So for now, it's time for question and answer. So if the participant have any questions or comments or would like to share something, please turn on your microphone and we can talk and we can share. Okay.
So, I have one question. Could you please give some example of the functional ingredients in buckwheat that is good for our health?
In the world? Excuse me.
In buckwheat.
In buckwheat, yes.
Mm-hmm.
So did buckwheat have any specific ingredient or like any specific properties that will be useful for our health?
Okay. Buckwheat is gluten-free and is a dietary source of starch, protein, vitamins, and dietary, especially fiber, is useful our health and phenolic compounds. And many studies is conducted in low gluten foodstuffs, and replacing high amount wheat flour is used.
Yeah, I have another question as well. So you mentioned in the abstract that you use the ingredients to study the bust skin or the boost skin. So could you please explain more what actually is boost?
Yes, this is a picture of boost. And some believe it is generated in China, but now Mongolian dishes are used in almost every day in Mongolia. The main ingredients are wheat flour. Nowadays, the dough is consist of 100% of wheat flour, and the filling meat, onion, and some I'm sorry, and sometimes and vegetable, especially it is beef and mutton. Mongolians eat both. It's very high consumption, especially on holidays, new lunar holiday. It is excessive consumption of the both can affect the digestive system.
Okay, so thank you so much.
Thank you for your question.
So any questions so far from the participants? So if not, so we ran out of time. Thank you so much, Ms. Solongo, for very interesting research. Thank you so much.
Thank you. Thank you so much.
Okay, so then we're going to move to the second presenters for the afternoon sessions. So Thiraphong Aumasa from Luang University, he's going to give a talk on the effects of extraction methods on physiochemical content and antioxidant activities of 9 Thai herbs tea. So please welcome Mr. Thiraphong.
Respected to all beloved audience, I am Thiraphong Aumasa. Today I'm going to present my research entitled Effect of Extraction Method on Phytochemical Content and Antioxidant Activities of 9 Thai Herbal Teas. So first of all, I will a little bit introduce you about the Thai Herbal Tea. So some of you will learn more about Thai Herbal Tea. What is Thai Herbal Tea? According to Thai FDA described in the notification of Ministry of Public Health, state that herbal tea is a product from 18 raw material that's shown in the figure 1. And it is used for consumption, and it is made by the boiling or infusing with the water. And Thai herbal tea can be mixed with another herbal tea. Thai herbal tea also can be mixed with the Camellia genus. For example, if I mix roselle with the green tea, so this came as the Thai herbal tea as well. And many producers try to produce Thai herbal tea in Thailand commercially, and this is the commercial brand that are available in the Thai market and very, very well known. And this is the product shown in this slide. And why we need Thai herbal tea? Because Thai herbal tea contains many bioactive compounds, for example, phenolic acid, flavonoid, tannin, and so on. And in Thailand, many plants are consumed as herbal tea, and they also use as the traditional treatment of diabetes. And a study report that more than 100 active plants in Thailand from 123 plant species were claimed as a diabetic use. And some of plants for diabetic treatment in the ethnic group that had been used for a century. For example, in the rural Thai, Mongolian. So you can see in the figure 3. And the antioxidant activity in the herbal tea come from mostly phenolic compound or the secondary metabolite of plant, and is divided into the basic phenol, for example, coumarin, garlic acid, ferulic acid, caffeic acid, and also divided into polyphenol, which has more than one aromatic ring, for example, anthocyanin, camphorol, quercetin, and tannin. So this depends on the variety of the and species of the plant. So they will have in the different phenolic profiles. And why antioxidant is important? Because antioxidant pose T mechanism, for example, suppressing ROS by enzyme inhibition, scavenging ROS, and antioxidant can protect the antioxidant defenses. And what is ROS? ROS is kind of free radical, which is the reactive oxygen species. So it's not good in our body, right? So if we have the free radical in our body and we have polyphenol, for example, flavonoid compound will donate hydrogen atom and then trap the free radical like ROS, and finally we will not have the free radical in our body. So next is the attraction of polyphenol. In order to get the higher antioxidant capability, so we have to get higher polyphenol content, right? So we need to know the nature of the polyphenol. For example, is there hydrophilic free polyphenol, bound polyphenol, or solubility? Because different polyphenol have different nature, right? So we can choose either conventional method or novel method. However, the most commonly used is the hot water extraction and the organic solvent extraction. Therefore, in this study, aim to determine relationship between phytochemical content and antioxidant activity, as well as to screen phytochemical content and antioxidant activity in different tea methods. So let's have a look at the methodology of this study. These are the raw material that has been produced by Suvirun Thai Tea Company Limited, as shown in the table 4. And coming to the overall methodology, 9 type of tea will be subject in different tea infusion method, including tea infusion and methanol extraction, and then measure the phytochemical content and antioxidant activity before select of 4 Thai herbal tea for the next study. For methanol extraction, the researcher used the 70% of methanol at 70 degrees Celsius. The extraction time is totally 20 minutes. And for tea infusion, will be done at 95 degrees Celsius for 5 minutes. And phytochemical content, including determination of TPC content, flavonoid content, and tannin content. And for the antioxidant activity, DPPS and FRAP assay will be determined. So coming to the result and discussion of this study. First of all, this figure 1 show the figure 1 show TPC content in different extraction method. So as you can see that we can have higher extraction capacity in the methanol extraction method rather than tea infusion. This is due to the TPC is specific for the garlic acid, right? Which is the low molecular weight compound. However, if we see in the GM sample, it has higher in the hot water tea infusion. Tea infusion give higher in the TPC content, right? So a study report that most of the phenolic compound in the GM is the genomic acid, which is the high molecular weight sample. So methanol is not suitable for the high molecular weight polyphenol like genomic acid in the GM sample. And coming to the total flavonoid content, methanol attraction also showed a higher content of TFC, as methanol has been reported as the best attraction solvent for low molecular weight compound like quercetin, because quercetin is also a low molecular weight compound which has only 303 gram per mole. While you can see in the GL and BC sample, T infusion give in the higher TPC content, and a study showed that the main flavonoid content in the BC and GL is the camphorol derivative, and this kind of the compound is high molecular weight compound as well. So this is the reason why hot water can attract higher content of TFC. And next is the TTC, or total tannin content. Total tannin content also shows similar trend in which methanol can attract higher TTC, because methanol is the acidic solvent, right? When we compare with the water, so tannin can be attracted in the low pH ranging from 2 to 5, and tannin can be stable in the acidic condition rather than alkaline condition when compared to the water. And however, another effect is when we use higher temperature during infusion, because infusion we use 95 degrees Celsius, right? So 95 degrees Celsius rather degrade the structure of tannin or tannic acid. So next, let's move to the antioxidant activity. First of all, let's have a look at DPPS assay. The results show that DPPS show opposite trend, in which infusion show higher DPPS activity, and the study show that acidic condition like methanol reduce antioxidant capacity during the assay. This is the assay effects. So next, for the FRAP assay, as you can notice from the previous slide on the TFC content, FRAP showed a similar trend or similar pattern. So TFC is very correlated to the FRAP assay. And the study also support that TFC has ability to scavenge the radical in the presence of 3 and 5 OS group or the catechol light structure flavonoid, as you can see on the top of the figure. So these are the type of flavonoid that give the higher in the FRAP activity. All in all, this table show the correlation between methanol and infusion. The results show that our phytochemical and antioxidant activity was positively correlated, and this table reflects that if methanol gives higher yield of total phenolic compound, so infusion method also give higher yield as well as if methanol gives higher activity of FRAP, so infusion will give higher activity of FRAP as well. So this is conclude that positive correlation. And coming to the conclusion of this study, methanol is more suitable for attraction of low molecular weight polyphenolic flavonoid and tannin compound, while water or tea infusion is more suitable for attraction of flavonoid from GL and BC sample. And methanol attract reduced DPPS scavenging activity due to the pH effect during the assay. For the FRAP has similar pattern as the TFC due to flavonoid accompanying catechol light structure in the C-ring, which is the good reductant. And the correlation analysis revealed that methanol and tea infusion has positively correlated. So tea infusion can be used interchangeably for attraction of phytochemical compound from thiable tea, instead of using methanol attraction, because it's a little bit toxic. So another finding from this study, we see the factor influence attraction method, including molecular weight, solubility, thermal and pH stability of particular polyphenol, interference, and attraction temperature. So in order to select for Thai herbal tea, index score will be used in this study, and the selected one is the Chrysanthemum barefoot, mulberry leaf, Genema leaf, as they have in high phytochemical content as well as antioxidant activity. So this is the future investigation. I want to see the ability of polyphenol to inhibit the alpha amylase inhibition, reducing the glucose finally. So this is the future investigation of my research. Thank you so much. This is all of my presentation.
Okay, so seems like you done very perfect for the time. Thank you so much, Mr. Thiraphong. So it's time for Q&A. So feel free to turn on the microphone. You can chat with the chat box for the questions.
Thank you very much for the presentation. I have some quick questions for him. So this is a research article you have, research work you have done by yourself. And
yes.
So the techniques of extraction in use, like in the novel part, is critical fluid extraction, ultrasonic extraction, and the third one, sorry, I missed it, third one was?
I use two attraction method, right? Tea infusion and methanol attraction.
No, but you use the extraction methods, like which processes used for extraction, like supercritical fluid or ultrasonic extraction?
Actually, only solvent attraction method, liquid attraction only.
And you use some equipment for that? No. You didn't use any equipment to facilitate the extraction process?
Yeah, I didn't use the ultrasound assisted or microwave assisted. Yeah.
Okay. Okay, just I got it now. And the second thing is that you have used the methanol for extraction solvent. Have you gone through the literature that methanol is very toxic for the residues that it leaves in especially the food commodities when we use it? It is very much, not advisable to use in the food applications.
Yeah, actually, I have read a lot of research about methanol attraction, but many research suggests that methanol attraction is suitable for the polyphenol from dry leaf, and then, but even though it's a toxic compound, right? So they use with another method to reduce the toxicity of the methanol after attraction. So in this study, I conclude that in the further study, I will use tea infusion method because it's capable, it has high in the attraction capacity, similar like methanol attraction.
I have one suggestion for you if you want to take it or not. But in my opinion, like you need to find some solvent that is a replacement solvent for methanol. Of course, there are a lot of ethical considerations we have to take into account, and you can use some combination of solvents for the extraction process that are less toxic than the methanol, and you can use some novel techniques like if you have the facility like ultrasonic extraction or high pressure to break the cells of the leaf, because ultrasonic and high pressure can do that. Even there are some reports that they use the pulsed electric field that makes a pore in the cells, and the poration, electroporation releases the cell component outside, and it facilitates with the solvent. The solvent washes out the components of the leaf cell or plant cell that contains the bioactive compounds, we can say. And the last part, I appreciate for you that you are going to test it in vivo conditions, right?
In vitro, yes.
Okay. I mean, it will be a kind of simulated digestive, condition. Okay.
Yeah.
Thank you very much.
Thank you very much for
All the
your
best.
recommendation.
But you had to consider on the toxicity of the solvent.
Okay.
Okay.
Thank
All
you.
the best.
So thank you so much for suggestion, and I think Mr. Thiraphong can apply some suggestion to his work. Thank you so much, Mr. Thiraphong. Okay, so we're going to move to the third presenters today in the afternoon, Gunthawan Apinanthanuwong. So she will give a talk on effect of extraction solvents on total polyphenols, antioxidant activities, and catechin profile of various tea types. So please welcome Ms. Gunthawan. So you can share your screen. Okay. So Gunthawan, yeah, you can start the presentation. Thank you.
Respected to our beloved audience, I am Gunthawan Apinanthanuwong. Today, I would like to present about my research entitled of the effect of extraction solvents on total polyphenol, antioxidant activity, and catechin profile of various tea types. So first, let me introduce you about the tea Camellia sinensis. So tea Camellia sinensis is one of the most widely consumed beverage throughout the world, which produced from the leaves of the plant of Camellia sinensis. And it can be classified into 3 types, depending on the degree of fermentation, which including the non-fermented tea, which is green tea, partially fermented tea, which is oolong tea, and fully fermented tea, which is black tea. So, and many studies reported that tea is a source of polyphenol compound, such as catechin, which contain the highest amount in tea leaves, and also it has reported to have ability to reduce the risk in the risk of the chronic disease, such as type 2 diabetes, cardiovascular disease, and also the cancer. So next, let's talk a little bit about catechin. So catechin, as I mentioned, that it presents in high concentration in tea plants, which is around 75%. And it is a colorless, water-soluble, and astringent taste compound. Many studies reported that it can prevent many diseases by its antioxidant capacity, which make it to be sensitive to high temperature and oxygen. And this shows show the major catechin compound that occur in tea plants, which is including epicatechin, epigallocatechin, epicatechin gallate, epigallocatechin gallate, catechin, gallocatechin, catechin gallate, and gallocatechin gallate. And also, catechin can inhibit the activity of alpha amylase, which is one of the key enzymes for starch digestion. So this slide shows some of the extraction methods to extract polyphenol, including supercritical fluid extraction, hot water extraction, solvent extraction, ultrasound-assisted extraction, and microwave-assisted extraction. And in this study, hot water and solvent extraction were used. So basically, the factors such as solvent type, aqueous solvent mixture, extraction temperature, and also the extraction time can contribute to the extraction efficiency of catechins from tea. And normally the extraction of phenolics from plant materials were often with different solvents such as methanol, ethanol, or acetone. Therefore, the aim of this study is to study the effects of extraction solvents on total polyphenol content, antioxidant activities, and also catechin profiles of green tea, oolong tea, and black tea. Moreover, I also determine the relationship of TPC, antioxidant activity, and total catechin content between tea infusions and methanol extract. So this slide shows the overall methodology. So the green tea, oolong tea, and black tea will be extracted by hot water and methanol extraction, then determine the TPC, antioxidant activity, and catechin content using HPLC. So first, start with the steps of tea infusion. Dry tea leaves will be mixed into 100 ml of 95 degrees Celsius hot water for 5 minutes with the continuous stirring, and then filter, then determine the antioxidant capacity, activity, total polyphenol, and catechin content. For tea methanol extract, it will be extract with 70% methanol, and then filter through filter paper, then centrifuge and determine their TPC content, DPPH scrap, and catechin content. So for the results and discussion, this figure shows the effect of different extraction solvents on total polyphenol content of these 3 types of tea, including green tea, oolong tea, and black tea. So the content of total polyphenol were found higher in methanol extract than hot water, which means it has higher extraction capacity due to phenolic compound has a relative polarity close to methanol. Therefore, it has higher solubility in methanol than water. Moreover, methanol is also suitable for extracting low molecular weight compounds such as catechin, which has molecular weight between 290 to 458 grams per mole. And furthermore, the result of TPC also corresponded to antioxidant activity. As you can see in this slide, methanol extract also showed higher extraction capacity for both DPPH free radical scavenging assay, as this assay used to determine the ability of polyphenol to donate hydrogen atoms or electron to free radical. So according to the graph on the left side, it means the anti-radical of tea is proportional to the total polyphenol content. And for the FRAP assay, which is on the right side, is the assay used to determine the ability to reduce the ferric ion to ferrous ion. Therefore, it means that methanol can extract higher TPC content than hot water, which also corresponded to their antioxidant activity. So this slide shows the effect on the individual catechin. So due to the high polarity nature of catechin, so catechin in tea leaves are normally extracted with the polar solvents such as methanol. So in this slide show the effect of extraction solvent on individual catechin, including GC, EGC, and C content. And the results show that the lower extraction capacity was observed in hot water extraction, while the higher one was found in methanol extraction, with a statistically significant except for GC content in green tea and oolong tea. And the result present in the same trend with other individual catechins such as EC, EGCG, CGC, ECG, and CG. So this slide shows the effect of effect on total catechin. So according to this slide, significant differences in total catechin was found in all 3 types of tea. So this also indicates the effect of tea processing on total catechin content. since green tea processing is non-fermented tea, so without the fermentation steps, it can inactivate the enzyme that responsible for the oxidation reaction, which is polyphenol oxidase. However, for black tea, it is a fully fermented tea. Therefore, catechin will be oxidized into the arubitins and the aflavin during the fermentation step. And this compound also responsible for the color and the astringency of the black tea. So we can say that the highest total catechin remains mostly in green tea, oolong tea, black tea respectively. This slide shows the correlation of the total polyphenol content, antioxidant activities, and total catechin content between tea infusion and methanol extraction. And according to this table, positive correlation were found in all parameters, which were shown to be statistically significant. So the data indicates that the higher TPC and total catechin content in tea extract with methanol could also result in the higher TPC and total catechin content in tea infusion or water extraction or hot water extraction, while the antioxidant activities also show the positive correlation as well. Therefore, this study can be concluded that the compound that extracted with 70% methanol showed the higher antioxidant activity and total catechin content than extracted with hot water. And 70% methanol is suitable for extracting low molecular weight compounds such as catechin. And the positive correlation were found in TPC, antioxidant activities, total catechin content between tea infusion and methanol extraction. For my future study, which is in progress, as this finding indicates that there is a high polyphenol in tea extract, which also have some study that reported that it is correlated with the inhibition of the digestive enzyme. Therefore, my current research will be study about the stability of tea catechins and the inhibition of starch digestion during in vitro digestion. And I would like to thank Lyon University for the funded and Thai Tea Surun Co Limited for support my raw material and also Tea Institute for the analysis. Thank you.
Okay, thank you so much, Ms. Gunthawan. So time for Q&A. Feel free to share your idea or questions. So maybe just for me, you said that you have the future plan to do about the digestive enzyme something. So could you please describe more what you plan to do about that topics?
So for about the digestive enzyme, as this is my part or one part of my research. So the next part will be study, as I mentioned that in tea sample it contains a high total polyphenol content. So total polyphenol content and which is related to the ability to inhibit the digestive enzyme. So I want to study about the stability of tea catechin in all three types, including green tea, oolong tea, and black tea, about their stability and also their inhibition activity of the digestive enzyme.
Okay, so thank you so much, Tab. So we still have a little time, so you can have question more.
Please, thank you for your presentation once again. Can you please go to the slide where you show the supercritical fluid, that model?
This one, right? Oh.
Yeah. Yeah.
Okay.
So, so you use this equipment for the extraction, right?
No, actually, this slide just show the extraction methods that that some research use, but for my research, I just use the hot water extraction and solvent extraction. Yes.
Means like this is in your literature. I mean, you quoted it as a literature, not as a methodology in your research.
Yes.
I'm sorry about that, but we ran out of time. Thank you so much.
Okay. Well, thank you very much.
Okay, may I invite next speaker, Mr. Tan Thai from Luang University.
Oh my God.
He going to talk about the fractal image analysis and Bruise susceptibility evaluations of impact damage in Guava. Okay, if you're ready, please.
Good afternoon, everybody. Today, my title is Fractal Image Analysis and Susceptibility Evaluation of Impact Damage in Guava. This is the first experiment of the mine thesis. In the development, Thailand is the sixth rank of the Guava production. And export value of the Guava production from Thailand is increased from 2,000 to 7,000 million tons. So the market, so the Guava is an important commercial food crops in Thailand. Bruise is more serious than other vibration and compression damage. In this development, previous research are studying some kinds of fruits and for using fractals of the different kinds of the trophies and number of drops to investigate the impact Bruise damage. In this table, impact Bruise damage were determined by the parameters of the Bruise assessment and color measurement in many kinds of the fruits. Image analysis is a rapid, more effective, low cost than other methods, and it is the non-destructive for fruit quality evaluation. Most of the researchers have been conducted to determine the fruit quality evaluation assessment by the image analysis in many kinds of the fruits. Based on the literature review, there has been no study and no report in Bruise impact damage and of the Guava in Thailand. Also, no study of the Bruise damage by image analysis. The Guava is a climatic fruit and it has a thin skin and easy to damage, Bruise damage during storage and transportation and post-harvest handling. Two objectives in this experiment. The first objective is to study and investigate impact Bruise susceptibility and quality of the Guava from different drop heights and number of drops. The second objective is to determine the impact Bruise damage of the Guava by image analysis. In this experiment, the Genji Guava varieties were used and some quality are determined. 50 Guava fruits were randomly selected to determine the fruit characteristics for estimation of the initial quality of the fruit and the maturity. In this experiment, RCT designs with the 5 treatments were used with the 5 applications in each treatment. The 5 treatments include different kinds of the drop heights and number of drops. The first treatment is the control no drops. The second treatment is the 0.3 meter drop heights with the 1 times of drop. The third treatment is the 0.3 meter drop heights with the 5 times of drop. The fourth treatment is the 0.6 meter drop heights with the 1 times of drop, and the last treatment is 0.6 meter drop height with 5 times of drop. In this experiment, the laboratory impact test were used. Is followed by the method of the disc paper. The stainless steel also used as a embedder. This paper shows the beauty regions of the guava fruits after day 0 storage and day 4 storage. After dropping, the guava fruits were stored at the condition of the 25 degrees centigrade temperature and 70% relative humidity and check quality. The quality measurements are embedded energy, bruising area, bruising volume, bruising susceptibility, specific bruising susceptibility, bruising score, color measurement, and image analysis. Bruising scores of the guava fruits were followed by the bruising score of the apple disc paper. After embed testing, the guava fruits were taken in the light box, and the guava bruising damage were preferred by the using of the image software. The original image were cropped and made grayscale image subplot with the threshold image. The selected using regions were converted into the binary image before determination of the FT analysis. For the model prediction and validation testing, Fractal dimension volume was determined, and the R-square validation calculated by this equation. In this table, the fruit weights are significantly no significantly different, and the other bruising assessments are significantly different. The 5 drops from the height of the 0.3 meter and 0.6 meter have higher bruising assessments than the single drops. So the number of drops is highly affected than the drop heights. And this figure shows the color parameters of the L and A value of the bruising damage. The control treatments are significantly higher value than the other treatments. The 5 drops from the height of the 0.3 and 0.6 meter have lowest value than the single drops. This figure also shows the color parameter of the B and chroma value of the bruising damage. This figure also control treatments have the significantly higher value than the other 4 treatments. 5 drops from the height of the 0.3 and 0.6 meter have higher color value than the single drops. So the increased drop height and number drop heights highly significant on color value. This is the result data analyzed by the Hemat-Pearson correlation method. The correlation between the FT value and bruising assessments of the especially bruising area and bruising volume are higher than the other color parameters. So FT value is a greatest correlations than the color parameter. This figure shows the image analysis for FT value due to storage condition. And control treatments have the highest FT value, and 5 drops from the height of the 0.3 and 0.6 meter treatment have the more bruising and deeper surface floor and lowest FT value. This figure also shows the FT value of the day 4 storage condition. This figure also control treatment have the highest FT value, and 5 drops from the height of the 0.3 meter and 0.6 meter have more bruising damage and deeper surface floor and lowest FT value. This figure also shows the FD value as a highest condition, higher conditions in the control treatments. And the lowest FD values are observed in the 5 drops from the height of the 0.3 and 0.3 and 0.6 meter. So FD value gradually increase with the increase of the Bruise damage. In this table, the highest R-square value occurs in the control treatments because control treatment is a no drop and no Bruise damage. And another 4 treatments, 5 drops from the height of the 0.3 meter and 0.6 meter have highest R-square and R-square validation value than the single drop treatment. It may be concluded that 5 drops from the height of the 0.3 and 0.3 meter have a greater than the color assessment and color measurement. So the number of drop heights have more affected than the drop heights on the Guava Bruise image impact. FD value is a higher correlated than the all color parameter. So image analysis for FD value, image analysis for FD value greater potential than the color parameters in the Guava Bruise impact image. The highest R-square value observed in the 5 drops from the height of the 0.6 and 0.3 meter. It shows a higher accuracy for Bruise prediction of the damage FD value. So FD analysis shows the greater potential than the color parameter to assess the impact Bruise damage of the Guava fruit. That's all my presentation. Thank you for your kind attention.
Okay, thank you very much for your nice presentations. So now it's time for questions. If you have questions, could you please turn on your microphone and ask Mr. Tentai? So any questions from audiences? Okay, may I have one question? Why did you choose the polynomial equation to explain or model the behavior of the Bruise fruit in your study?
Yes. Pardon?
Yes, my question is why did you choose polynomial equations to explain the behavior of the fruit?
Yes, we compare the polynomial equation and the R-square validation. So R-square validation and R-square value is the same condition. Can be seen the highest value occurs in the at the 5 drops with the height of the 0.3 and 0.6 meter. Instrument.
Yes, I mean, did you compare with the other model or other equations?
We have simple linear, we have polynomial. Why you select polynomial? Do you have any reason to support your decision?
It's a correlation coefficient. It's a polynomial equation.
Okay.
It's a best condition.
Okay. Thank you very much for your answers. So, shall we move to the next speaker? I invite Mr. Mojtaba AZARI-ANPAR from Université, Lyon. He's going to talk about the effect of different polysaccharide on the antibacterial activity of niacin. If you are ready, please share your screen.
Yes, sure. I'm ready.
Okay, go ahead.
Okay. Hello everyone, I hope you are doing well. First of all, I want to thank you for dedicating me this time, and especially on behalf of my colleagues at Biodemia Research Unit in France and in Iran. This is Mojtaba AZARI, as joint PhD students at the University of Lyon. Actually, my university in Iran is the Ferdowsi University of Mashhad, so I could accept as Couturier students since 2019, University of Lyon 1 in France, under supervision of Pascal Derov and Nadia Ola. Since I don't have enough time, I'd better get to the point about my subject we have done. As you can see, my subject entitled Effect of Different Polysaccharides on the antibacterial activity of nisin, which I will be explaining to you with this view. Okay. Before starting my subject, I would like to explain. Before starting my subject, I would like to explain about our research unit in France briefly. In fact, the Biodemia Research Unit created on 2011 under the dual supervision of University Lyon 1 and AZARI in Lyon. Biodemia has developed innovative strategies for perishable foods biopreservation based on the association of bioprotective LAB strains with biopolymers, for instance, antibacterial biomolecules, extract, and bioprotective lactic acid bacteria like polysaccharides and proteins. So let's get started. First, we have an introduction about nisin. As you maybe know, nisin is a bacteriocin produced by a group of gram-positive bacteria that belongs to Lactococcus and Streptococcus species, especially Lactococcus lactis. Nisin has antibacterial activity against foodborne pathogens like Listeria monocytogenes, and is used as a food preservative quite worldwide. So, as you can see on picture, it bonds through interaction between rings A and B with the bacterial cell wall and leads to killing unwanted bacteria. Nisin molecule has a strongly amphibic character, as you can see. With decreasing pH, the solubility of nisin increase. In fact, it is important for us to consider it as a food preservative. Nisin as also cationic due to the presence of some positively charged residues, for example, some lesions and some histidine. As you know, on the other hand, polysaccharides are used extremely as an important food ingredient, and especially for this reason, for example, hydration, gelation, emulsification, thickening. We can be referred to the following examples. For example, for instance, sodium alginate in dextran. As you know and explained to you, sodium arginate is a polysaccharide that is used in food, and knowing the structure and how to use it. I mean, what type of charge has it, or what characteristics it is. As I mentioned, alginate is negatively charged. From another hand, we have citrus pectin. Pectin is consisting of such as rhamnose, arabinose, galactose, and xylose, and has negatively charged. But from another hand, dextran is a linear structure, and it has a neutral glucose chain. Furthermore, a full understanding of the interactions, structure, and quality properties relationship of polysaccharides with some food constituents, especially proteins, as one of the important compounds of food is still needed. However, nisin antibacterial activity in foods can be limited by its interactions with other food constituents like polysaccharides. In this case, when it comes to interactions, it may be asked ourselves, is nisin antibacterial activity affected by polysaccharides used as thickening agent? What about interactions between polysaccharides and nisin? In this work, MIC and MBC of nisin were determined against two bacterial strains, I mean Listeria innocua and Rhizophila. We used the twofold serial dilution method with concentration from 40,000 to 78 IU per L. All samples were prepared in TSB alone, I mean control, and versicle were prepared with 1 gram per liter of each polysaccharide. I mean sodium arginate, citrus pectin, high molecular weight dextran, and low molecular weight dextran. And finally, all the samples were prepared after 24-hour incubation at 30 degrees. As you can see, the results showed us that Rhizophila was more sensitive to nisin than Listeria, and sodium arginate resulted in a fourfold increase of MIC and MBC of nisin for both strains. In return, pectin addition did not affect MBC of nisin, while it resulted in twofold decrease of its MIC with both strains. Concerning low molecule and high molecular weight dextrans, there were not any effect MIC and MBC of nisin for both strains. I would like to illustrate how to interact between nisin and sodium arginate. As I mentioned, the sodium arginate is high negatively charged, and on the other hand, nisin has positive charge. We can guess easily what happens. It should be noted that according to literature, sodium arginate is more negatively charged than bacteria. So it leads to interacting sodium arginate and nisin, not bacteria. Therefore, bacteria can grow easily without any effect of nisin. On the other hand, This slide is related to interaction of lysine Z and pectin. It may be is for this reason that first the lysine is captured and interacted by pectin, and then as bacteria has a more negative charge than pectin, so lysine separate pectin and bind with bacteria. Finally, lysine can restrict bacteria growth. In other words, pectin can facilitate lysine against bacteria. However, we can see twofold decrease of its MIC. Conclusion. It's proposed that lysine antibacterial antibacterial activity loss in the presence of sodium alginate is due to the complexation of cationic lysine by this anionic polysaccharide. Lysine complexation would limit the amount of free lysine interacting with the target bacteria. Highly methoxylated citrus pectin, which is less negatively charged than the surface of a bacteria, would not complex lysine and prevent its interaction with the surface of bacteria. Interestingly, dextran, which can be produced in situ in fermented dairy products by Leoconos of mesenteroid, these strains does not affect lysine antibacterial activity. Thank you so much for your attention.
Okay, thank you very much for your presentation. Now we have 2 minutes for questions. If you have questions, please turn on your microphone and ask Mojtaba. Please.
Ask me, please.
Hello. Thank you for your presentation. I want to know about the MIC and MBC. So could you please go to the slide?
Yes.
So MIC, there's you have like 4 samples of different samples treated with different polysaccharides, like you mentioned, alginate,
Yes.
pectin, dextran, and low and high molecular weight.
Yes.
So how can you show that there is a difference in the MIC and MBC?
As you can see, this part is related to control. Okay, it's actually, it's related to Listeria innocua and the Rhizophila. You can see easily, for example, if you can see MIC and MBC and compared with sodium alginate, you can show some difference between 2 samples. You can see easily. But for two samples, 2 dextrans, we cannot have difference between MIC and MBC.
That's no difference.
But from another hand, in Rhizophila, you can compare with control and sodium alginate. We have the same data. Both of them in Rhizophila and Listeria Listeria innocua, sorry. But since Rhizophila more sensitive than Listeria, you can see different data. For example, we can use less concentration for killing of Rhizophila. Sorry. You can see this concentration. Actually, we use low concentration for Rhizophila than Listeria innocua.
So in short, like in some samples, the MBC is the double of the MIC.
Yes.
Yeah, thank you very much for your answer, and I hope you can explain me the mechanism in the chat. Thank you for your answer. Yeah, because
Okay,
of the
thank you
time.
very much. You can contact using a chat box. Next, I would like to invite Mr. Peeraphat Prempree. He's gonna talk about the storage life extensions of Rong-Rein rambutan using short-term super ATM, use super atmospheric oxygen and anoxia treatment. Okay, please.
Okay, do you hear me?
Very good.
Good afternoon, everyone. My name is Peeraphat Prempree. Today, I would like to present my master research about storage life extension of Rong-Rein rambutan using short-term super atmospheric oxygen and anoxia treatment. First of all, I will present today according to this outline. Start with the introduction, objectives, materials and method, result and discussion, conclusion, and references. So, start with the introduction. Rambutan is the economic food. It provides the value of the export around 294 million Thai baht in 2019. The rambutan food is normally exported around the Asian country as a fresh food, but it's also exported as a frozen food to the Canada, USA, Europe, something like that. In Thailand, the great quality or the highest quality of rambutan can reach the price around 20 to 25 Thai baht per kilogram. For the maturity index of this food is normally use the red color on the peel or just only use the minimum of the 16% of the total soluble solid. This food can be acceptable for the harvesting after the color base for around 16 or 28 days. The peel and the spinton still brightly colored. In my research, I used the stage 4 that I circle here. It provides both peel and the spinton allow the 30% of the red color. The main problem of this food is burning of the peel and spinton due to the rapidly loss of water with the spinton. This food can be stored for a long time, allow more than 1 week if stored in the 8 to 15 degrees Celsius with high humidity. The objective is to investigate the effects of short-term super atmospheric oxygen and short-term anoxia treatment on post-harvest quality of rambutan food during cold storage. For material and method, start here. The rambutan foods were harvested and transported from my orchard in Tas province and then transport for 2 days to Chiang Rai. After that, the foods were sorted with the uniform size, color, and without a defect. After that, the foods were cleaned or rinsed by the chlorinated water with 200 ppm for 2 minutes. And then the foods were moved into the airtight container and treated with the boiling gas at 12 degrees Celsius with high humidity for 1 day. The treatment 1 treated with the normal air or the control. Treatment 2 is super atmospheric oxygen or 100% of oxygen. And the last one, anoxia treatment or 100% of the nitrogen gas. This is the setting diagram of the gas treatment. Start with the 100% gas cylinder here, and then the gas go to the fast to humidify the air, then adjust the foliage by the flow controller, or it can call the manifold to adjust the foliage around 200 or 300 milliliters per minute. After that, the gas go inside the tank or inside the container by the inlet and continuously flow by the outlet. After treating the food for 1 day, the foods were packaged in the perforated plastic bag and stored in the cold room for further analysis at the 12 degrees Celsius. Let's see the result. In the figure, the control we indicate by the circle symbol, the super-empiric oxygen indicated by the triangle, and the last one, anosmia, by the square symbol. The first one, this result is the weight loss, percentage of the weight loss. After treating the food with the gas, super-empiric oxygen and anesthesia treatment can maintain the lowest weight loss at the day 3, day 6, and day 9, lower than the control. At day 9, the weight loss of the control go over the acceptance line. The next one, this figure on the left side is the total soluble solid, and the right side is the digestible acidity. During the cold storage, the total soluble solid of rambutan increased, but after treating food with the gas treatment, both anosmia and super-empiric oxygen can lower the TSS. As you see here, also for the digestible acidity, it was lowered by the anesthesia treatment, and also it's significantly lower by the super-empiric oxygen too. The next one, according to the previous figure, TSS and TA was reduced by the gas treatment. So TSS per TA is show the result of the increasing by anesthesia treatment at the day 1 and day 3. The next one, respiration rate. After treating food for 1 day, the respiration rate of both super atmospheric oxygen and anesthesia treatment were increased to higher than the control. And then after 3 days of the storage, only the anesthesia treatment still higher than the control, but the super atmospheric oxygen gradually reduced to lower than the control until the end of the storage. This means at the end of the storage, super atmospheric oxygen can reduce the respiration rate. The next one, the figure A and the figure B, these two parameters are the decay index and burning score. It shows the lower score of the decay by the super atmospheric oxygen and anosmia. If the result go over the acceptance line, it means it's not unacceptable by the consumer. And the result found that after the storage food for 6 days, the control is unacceptable. And for the 9 day and at the day 9, both control and the super atmospheric oxygen was unacceptable. Also for the burning score, it showed the same pattern with the decay index. Anesthesia treatment can accept until 9 days. Okay. This figure shows you the rambutan food for the treatment at the day 0, and then the next figure, the next figure is the rambutan food after storage for 9 days. The annotated treatment show healthier food than other treatment. For the conclusion, short-term super-atmospheric oxygen and anorexia significantly reduce weight loss, TSS, TA of rambutan when compared to the control. The anorexia increased respiration rate of rambutan food until the end of storage, while the super-atmospheric oxygen increased respiration rate after 1 day of the storage, then gradually declined until the end of storage. Both anorexia and super-atmospheric oxygen can protect against frost and delay peel burning compared to the control. So, anorexia treatments were the best in maintaining quality and extending the storage life of rambutan for 9 days, while the food treated with the super-atmospheric oxygen and control was acceptable for only 6 and 3 days, respectively. I would like to acknowledge the financial support for postgraduate students provided by Luang University, Thailand. Thank you for your kind attention. Any suggestion or question, feel free to ask me.
Okay, thank you very much for your presentation. So now it's time for question. We have 3 minutes for question. Please turn on your microphone if you have questions.
Hello.
Hello.
I would like to ask, is there any specific reason why did you choose I saw your sample, you choose like the 30% redness of the peel of the rambutan? Is it any because you show us like few picture of like few different redness of the rambutan? Yep, that one. Like why don't you choose like the third one? Why is it the fourth one? Is it any specific reason for that?
Your question is mean why I don't use any stage, right? Why I use the stage 4, right?
Yep.
Oh, because rambutan is the non-climateric food. If I use the stage 5 or stage 6, it will how can I say, it will lot easier because the food is softer than the stage 4. But if I use stage 1 or stage 2, it's not ripened enough. So the stage 4 is the best one for the quality, for the taste, the flavor, something like that.
Okay, thank you.
Welcome.
Yes, we can have one more question, one more short question.
So if we don't have any more questions, so thank you so much for all 6 presenters for the first part of the afternoon sessions. We will have around 10 minutes break, and then we're going to continue the second part. So could you please be on time on 14:45 here? Thank you so much, everyone. Oh, before we have a break, we need to have the group photos again. So could you please turn on your videos, the camera? So and then the next person gonna be the person who's gonna record the picture. So I'm gonna count 1 and 3, then you keep smiling. So 1, 2, 3. And then second one, 1, 2, 3. And the third one, 1, 2, 3. Thank you so much, everyone.